Hi guys, hope you're well. Welcome to today's screencast for tomorrow's lesson. We're moving on to the energy systems. Okay, so we need to start to think about the effects of exercise and sports performance on the energy systems. Today's lesson we're going to go through, or the screencast I should say, is going to go through ATP and the role of ATP in exercise, and then we're going to go through the ATP Pc system, which is one of the energy systems we need to know. So first of all, energy for exercise. Okay, let's just get started with a bit of an introduction. So we need a constant supply of energy so it can perform everyday tasks. Okay, so from writing on a piece of paper through to kicking a football. The more exercise we do, the more energy is required, i.e. the more energy we need. And obviously the intensity and duration of an activity play an important role in the way in which energy is provided. So, for example, activities that require short bursts of effort, such as sprinting, jumping, throwing events, they require a large amount of energy over a short period of time. And in contrast, we have something like marathon running or kind of cycling require continued energy production over a longer period of time at a slower rate. So therefore, the different energy systems facilitate these processes. Okay, so the energy systems of the body can function aerobically, so with oxygen, or anaerobically without oxygen. So movements that require sudden bursts of effort are powered by energy systems that do not require oxygen, i.e. anaerobic systems. So 100-meter sprint, throwing a discus, high jump, long jump, triple jump, weightlifting, they require anaerobic energy systems, which we will be going through one of those today. And then prolonged activities such as a marathon, cycling over long distances, triathlons, they require aerobic energy systems. They require oxygen for energy. We need to realise that all the energy systems work together. The type of activity and its intensity will determine which system is predominant in a particular sport. So, first of all, these are the three energy systems. Okay, so three energy systems that we use all regenerate something called ATP, which we're going to go on to. Okay, I'll go on to ATP on the next slide. All we need to know, the three energy systems that we are focused on are the ATP Pc system, also known as the lactic system, the lactate system, known as the anaerobic system, and then finally the aerobic system. So we should know straight away, these two first ones here, these are anaerobic systems. We do not require oxygen to use these systems here. However, the aerobic energy system, we require oxygen for energy. So, as said, each energy system is suited to a particular type of exercise depending on the intensity and duration and whether oxygen is present within that. So, first of all, the role of ATP in exercise. ATP stands for adenosine triphosphate, and this is the only usable form of energy we have in the body. Okay, this is what we need to create energy, whether or not it is a marathon, whether or not it is a sprint, whether or not we're picking up a pen. We need adenosine triphosphate, ATP. It is immediately accessible form of energy for exercise. Okay, so ATP is within the muscle and it is immediately accessible straight away. However, it doesn't last for very long, and it's something we're going to go on to in a minute. Okay, so the energy comes from foods that we eat, such as carbohydrates. This has to be converted, so the carbs that we eat have to be converted into ATP before the potential energy can be used. So ATP, adenosine triphosphate, what does it stand for? It means it's one adenosine molecule and three phosphate molecules. So together it makes adenosine three triphosphate, so 3-phosphate. That is what ATP stands for. We need to make sure we've got clear notes on these, by the way, guys, because it is important. So adenosine triphosphate is made up of one molecule of adenosine and 3 phosphates, ATP. Okay, so how ATP is used within exercise. I'm going to go through this here now, but I've also got a visual tool for you to use later on, which is hopefully going to help you understand this in a bit more detail. For energy to be created or produced ATP needs to be broken down. So we have enzymes that are used to break down the ATP. So the enzyme that is used to break down ATP is called ATPase. ATPase is the enzyme used to break down ATP into ADP, adenosine diphosphate, and one single phosphate. So we need this to happen for energy. Now all that we've done is we've got adenosine triphosphate, one adenosine, 3-phosphate. ATPase has come along and taken away a phosphate, and then boom, energy is created. So now we are left with one adenosine and 2-phosphate diphosphate. Okay, so adenosine diphosphate is just 2-phosphate left. This is useless for us. We can't do anything energy-wise with adenosine diphosphate. Therefore, this has to be replenished, and we're going to talk about that with regards to one of the next energy systems we're going to look at. But for now, this is the role of ATP within exercise. This is not an energy system. This is just a role of what adenosine triphosphate does. So that is used for energy. So ATP is found within the muscle fibers. They're used very quickly. It lasts 2 to 3 seconds. It does last no time at all. Therefore, it needs to be resynthesized immediately. 2 to 3 seconds gives you nothing really. So it needs to be quickly resynthesized. And we're going to talk about how that happens. So ATP can provide several powerful contractions lasting only 2 to 3 seconds. And this can be shown in the graph similar to the one below. So concentration of ATP, 3 seconds, 10 seconds, 6 seconds, 2 hours, and so on. That is our ATP store. Okay, so we have a full concentration of ATP, but within 3 seconds, it has gone. Now, I told you at the very start, ATP is our only form of energy. It's what we use for energy. Therefore, we need to get this here back up here. So we need to replenish it. We need to resynthesize it. So this is how it happens. So resynthesis of ADP is done through the joining of a single phosphate and ADP. This energy regeneration is only possible through one of the 3 energy systems, and this is the one we're going to do today, and it's the ATP Pc system. This is an anaerobic system, and this system lasts for about 10 seconds. So again, it's very short-lived. So what's happened is, if we just quickly recap, we've had ATP, we've needed energy, therefore ATPase comes along, takes away a phosphate, and we've created energy. We are left with ADP. We need to get our ATP stores back up high. Therefore, what happens is it's resynthesized, and it's resynthesized through the joining of ADP and a phosphate. However, what we need to know is how that happens, and this happens through the ATP Pc system, which we're going to go through now. So once ATP stores are depleted, this triggers the release of creatine kinase, which causes phosphocreatine to be broken down anaerobically. Now realise that right now is probably over your head and doesn't mean much, but hopefully the next thing we do is going to try and make that all apparent for you, okay? First of all, we're just going through, again, this is just a visual aid to help with the breakdown of ATP. So there's ATP, adenosine and 3-phosphate. When a cell needs energy, this high energy bond is broken down, okay? So it breaks down the bond between the phosphate groups, and what does this is ATPase. Okay, so ATPase comes along, we need energy. So ATPase, the enzyme, comes along, breaks down that high energy bond, and then we have energy. So now we have energy for a muscular contraction. That is ATP done. Lasts 2 to 3 seconds. That is it. However, we're onto the ATP Pc system now. So because this lasts 2 to 3 seconds, we need to rebuild ADP, which is this, 1 adenosine and 2 phosphate, ADP. we need to build this back to ATP because ATP is what we need for energy. So a muscle cell obviously has a small amount of ATP. As I've just said, it lasts about 3 seconds and it is used immediately. There's not enough for it to last any longer than those 3 seconds. So to replenish ATP levels quickly, we use the ATP Pc system. So what happens is so now we're left with ADP, and what we have is something called phosphocreatine, i.e. ATP Pc. The Pc stands for phosphocreatine, and this is a high energy compound. Okay, so what we need to do is have this broken down so that we can take this phosphate to join it onto the ADP to make energy. So what happens is phosphocreatine, it's stored within the muscle. Creatine kinase is an enzyme. It comes around, just like ATPase splits up the ATP. Creatine kinase splits up the phosphate and the creatine. So we have just a phosphate left. This phosphate here resynthesizes with ADP to make ATP. So ATP is resynthesized from energy released from the breakdown of phosphocreatine, and now we have ATP. And that right there is how the ATP Pc system breaks down and creates ATP. So what happens now is we'll just go through that whole process again. So ATPase would come along as an enzyme. We need energy, break off ATP to create energy. We're left with ADP. Creatine kinase comes along, breaks up phosphocreatine just into a phosphate and creatine. That phosphate joins ADP to make ATP. We have energy again. As I have said, this energy system is anaerobic and it only lasts for approximately 10 seconds. And then we have some advantages to it. So instant energy for explosive contractions. So that happens really quickly. The ATP Pc system, that happens really quickly. We don't need to wait for oxygen for any chemical reactions to take place to have energy. We have it straight away. ATP resynthesizes quickly due to Pc stores and simple reactions. These Pc stores, phosphocreatine, they're in the muscle already. We don't have to wait for them. They're there in the muscle waiting for us to use them. And Pc resynthesis is quick, so recovery times are short. We do not have to wait for oxygen from the lungs to get transferred in the blood all the way to the muscle, so then a chemical reaction take place to then have energy. It's already there within our system. Disadvantages to this system. So last advantage, which is a big advantage, no fatiguing byproducts. Carbon dioxide is not produced from the ATP Pc system. Disadvantages, small stores of Pc. It only lasts 10 seconds. So after 10 seconds, we need to move on to another energy system. We can't use the ATP Pc system. Provides energy for 10 to 15 seconds at peak. 1 mole of ATP is made per mole of Pc. So it's a 1-for-1 transaction that's taking place. You'll find out later on why that is a disadvantage when we go on to the aerobic energy system. So just to clarify, the ATP Pc system supports high intensity exercise for a short period of time, approximately 10 seconds. These are things such as sprinters, javelin throwers, shot putters, etc. If exercise continues at high intensity, these stores will only partially replenish. They won't replenish fully, constantly, all the time, so they'll eventually drop as there'll be not enough energy available for creatine and phosphate to reform. So after this energy system, we move on to another energy system, which we'll be doing in next lesson. Make sure you've got your notes down on that. I realise it is not easy. You might have to watch it 2 or 3 times. We'll recap it in lesson, go over it in lesson, and make sure that we've got this understood. Cheers, guys. Thank you. Bye.